Okay, everybody, moving on to the next one. So Brad just told us like the importance of BGP and how much you can do to secure it and all the elements to be considered. Our next speaker, Dr. Ritesh Mukherjee, who's a product line manager at Nokia, is going to tell us what could happen if things go wrong. So a little bit more on that. It's tales from regional operators. So take it away, Ritesh.
Okay. Hi, everybody. My name is Ritesh Mukherjee. As Mark said, I work at Nokia. I'm going to talk about some BGP security. Before I begin, three things. One, Mark, you guys have done a fabulous job starting Tornog. I really appreciate it. I don't know, you guys will see this as just one event today, but over the time, you will realize you guys have made something much bigger than a single event. You have created a community, which is really going to help. Second, I teach part-time at Northeastern. I teach cybersecurity, and sharing is caring. We take examples, and I have many examples today. It doesn't mean those operators or those customers did anything right or wrong. It's just sharing and caring. Once you learn from incidents, you learn things, and hopefully you don't repeat them. That's how the industry learns. That's how the community learns, and the community grows. And third, I changed my slides slightly. One, there was a great RPKI talk before this, so I don't need to talk about RPKI, what it does, and so on again and again, but I'm going to show a demo for a tool which we are going to open source. I just received an OK today morning to open source it. Basically, sign a paper which says if this brings down a network, Nokia is not responsible, and I can get fired or something like that, but we're going to open source it. I don't have the link, obviously, here, but we will, if you guys reach out to Mark or somebody, we can pass on that link. So let's talk about BGP security. There are two parts to it, operational hygiene, and I'm going to talk about that. This is the non-sexy part. Why? No one writes RFCs about, hey, you got to have this filter, you got to do this. No one goes to IETF and publishes an RFC on that, but you got to do all those things. The others, as Brad pointed out, RPKI, ASPA, and all are great, and we need to follow them and do them. I'm going to show how it can be done with today's routers. You don't have to wait. You don't have to wait for vendors to implement, and so on, and also you can do other stuff. We'll talk about that. 4:44 a.m., early in the morning, everyone's sleeping, but best time to do network upgrades. Rogers is in the middle of a 7-part upgrade, 7-phase upgrade. They are at phase number 6. All the 5 phases before have gone well. They decide to push the button for the 6. What it does, it makes a config change that deletes a policy filter. The normal setting keeps BGP, the internet table, BGP internet table from flooding to OSPF. This now goes down. The filter is gone. What happens then? Obviously, within minutes, the policy filter is removed. The full internet BGP table is redistributed to OSPF. Obviously, the link state databases are flooded. There's messages. All the core routers, they are not designed to handle this kind of memory and CPU dump, which they are getting now. They all stop working. What happens then? They stop forwarding traffic. Everyone told us, make a converged core. It's going to be so much greater. It's going to be better. You will have, why are you operating 2 cores and this and that? And make everything a single. You'll save money. Well, now you also took everything down when those core routers went down. Voice, wireline, wireless, wireline, voice, 911, everything. The impact. 1/3 of Canadians lost connection. It lasted for 19 hours. Why? It was a converged core. So the out-of-band management traffic was going through that converged core also. You couldn't reach any of these routers to reset them or to change anything on them. You had to physically go and reboot the routers or make changes. It takes 19 hours to reach every router and make changes. Thousands of prefixes were drawn. 911 calls failed. Why? Our phones are designed to use any network. Well, the network is not down. The core routers are down. The wireless network is up. The phones are connected to the base station. They think they are working. So you can't make 911 calls because the calls are going, and the core is not forwarding those packets. Interac is down. Canada's debit card payment system is down, obviously. Nothing is being forwarded, and roaming is cut off. At this point, obviously, nothing is going through the core. Yeah, CRTC, they obviously hired an external company to do some analysis, what really happened, make some recommendations. The report is available. You guys can read about it, obviously, or you guys might have already read about it. 3 things which I took from that report, which I wanted to sort of talk about today. There was no route limits. Yes, the policy filter was removed, but there was no limit how much OSPF routes were getting flooded. Why didn't you stop after a while? Why didn't you have some sort of guard which said, after this prefix count, you can't distribute routes this way. You can't constantly keep flooding. No overload protection. In hindsight, it makes so much sense. If something is consuming the CPU so much, stop doing that thing. Yeah, now it makes sense, but no, it didn't. There was no protection of that kind. Modern routers are designed to do stuff like that. Any process sort of taking 100% of the CPU should be stopped. Well, it didn't. And of course, we talked about it. Keep your out-of-band management. It's called out-of-band management for a reason. It has to be out of band. If it goes to the same routers which your core is, and the core is down, then obviously nothing can be done. But let's be clear. This was an operational failure. Everyone learned from it. There were CRTC findings and so on. And now everybody knows, don't do these things. So BGP works. Well, there are many things we take for granted in BGP. Just because it has been doing such a good job for such a long time, we forget. One of them, RPKI, ASPA, which I'm also going to talk about. Why didn't we do all of this before? Well, it was all working, and things were happening. Yeah, there were some incidents, and I'm going to talk about some of these, but we didn't bother or think about we need to fix it. Now we are. And we need to do that, and we need to do it quick. 2020, 2 years before this failure, there was another incident in which Rogers was hijacked. What happened? An AS, a small AS based in the US, Tulix system, they had a route optimizer, and what route optimizer is supposed to do? Publish more specific BGP routes. And the internet works great. We work on longest prefix match, the better prefix, go to that. Just drop everything else. So they unfortunately announced a /19 carved from Rogers /11 aggregates, and longest prefix wins, so all the traffic now got black holed. They're going to Tulix systems. Some operators during that time had already started RPKI validation. If RPKI validation was done, yes, they wouldn't go to Tulix systems because you would say, no, you are not allowed to say these routes. Brad just gave a talk on that, go to the registry, publish your prefixes and so on, sign it, cryptographically sign it, and so on. We would verify it. Systems like Telia and others, they would verify it and say, no, I'm not going to accept this because you're not allowed to say this route from your side. But we didn't. Why am I bringing this up? Well, this happened in 2020. Until 2025, we didn't start verifying prefixes. Bell started deploying route origin validation in 2025. So for 5 years, we knew this problem existed in Canada. We didn't decide to fix it. We just said, hey, it works. No one's going to do it again. It was a mistake. Yeah, well, people have learned from that mistake. Bad actors have learned from that mistake. Also, they know they could do this and bring the system down if they want to. Well, even they were not paying much attention to BGP because they didn't use it much, but they could have. My moral of the story is there was so much time passed between them, and the adoption took so long, but we continued operating as is. We don't want another 5-10 years to wait before we adopt RPKI, ASPA, and other things. We should be doing it sooner. These are not just distant theoretical problems. They are happening now. These are Canadian incidents affecting Canadian customers and users and operators, and we need to sort of fix these problems now. So 2 things. Operational hygiene. We learned we need to keep doing that. Have redistribution guards, overload protection, prefix limits, have labs to verify things. We heard the morning presentation on digital twins. Yeah, great way. Make digital twins of your networks to verify things. Why aren't every network operator doing that with having full digital twins of their network and so on? We need to get there. And of course, have true out-of-band management. Now let's talk about the next section, which is routing stack, routing security now with origin validation, ASPA. I also say BMP. We already have the ability to sort of take BGP messages from routers today and do all sorts of validation today. We don't have to wait. We don't have to wait for vendors to implement anything. We can do it today. Invalid route retention hygiene, peer communication channels, and I'll talk about peer communication channels, why. You need to know, you need to tell your upstream providers, hey, no, I'm not going to. You need to also start doing ASPA. You need to start doing RPKI. Otherwise, just me doing it in isolation has no value. You need to tell them to do it, and you need to know how to reach their NOC if anything goes wrong and tell them, no, you got to drop these routes. And I'll talk about why. I'll give some examples. Let's talk about a hack. 1.1.1.1, many of you might be using it. It's one of the most popular recognizable DNS addresses. It's debatable, 8.8.8 is also good, but 1.1.1 is popular. It's Cloudflare's obviously public DNS resolver. It went down on June 2024. They were using route origin validation. They had RPKI, but we'll talk about why it didn't help. 300 networks in 70 countries impacted. How did that happen? An AS in Brazil, Electronet, announced a more specific, we talked about it, longest prefix match, always gets us. 1.1.1/32, a more specific route, they announced that. At the same time, there was another issue, another internet exchange or ISP in Brazil, Nova, they leaked a /24 to Tier 1. What happens? A Tier 1 provider now took that /32 and announced it. So every downstream ISP from that Tier 1 is now sending 1.1 traffic to this Tier 1 and black holing it. 1.1 is not visible in 70 countries. Cloudflare detects the issue. It takes them 72 minutes to find out what is happening. Why 72 minutes? They were not using BMP. They could have used BMP to stream this data and figured it out in seconds. I'll show a demo. It can be done. But they didn't. The hijack was resolved, but the route leak was not. So you need to do both, RPKI and ASPA. The route leak obviously was solved next day when Nova finally stopped sending these announcements. Why was this such an issue? So Cloudflare had signed their RPKI 1.1.0/24. And you're not supposed to, in the default free zone, take /32s, but this Tier 1 was. Difference now is this Tier 1 accepts this /32 and black holes all traffic. They were not doing ROV, or what we call origin validation. They were not validating the routes they are getting. So anyone who sends them, even though Cloudflare is doing the right thing, they have signed their RPKI object, someone else is sending them something else, you're not validating. It's the same thing, right? I mean, if let's say Mark, he calls up Visa and says, tomorrow I want to open a credit card as Ritesh, and if Visa doesn't verify who's Ritesh, nothing can be done. The same way, if you don't verify the RPKI objects, it's of no use to you. And of course, at the same time, Nova had leaked an upstream message to Tier 1, which is causing a double whammy. So a hijack and a route leak together. 300 plus networks in 70 countries lose access to 1.1.1. It's not just RPKI, which is the issue here. They only didn't do RPKI, they didn't do ASPA, everyone didn't do their job, that's true. But that's one of the reasons. But don't accept /32s in the default free zone. Second, longest prefix wins. which means we need to be careful what we are doing, and no path filtering. They were not verifying that peer 1 is not an upstream provider to Cloudflare. So they should not have taken the route from Nova and just started sending messages accordingly, redistributing it accordingly. The moral of the story is you can sign your prefixes, but if your upstream provider or your peers upstream or the internet exchange does not enforce route origin validation, your traffic can still be hijacked, which is why you not only need to do it yourself, you need to tell your peering partners they need to do it as well. Otherwise, you doing it in isolation is not much helpful. Doesn't mean you shouldn't start, you should, but it's not that helpful. What would have helped? Doing all of these three things. Layer 1, it's not a layer 1, it's not the OSI layer 1, but layer 1 of protection. Partially effective, yeah. If you enforce route origin validation, correctly rejected the /32, if the tier 1 had done it, yes, it wouldn't have black holed the traffic. One problem would have been prevented. Layer 2, ASPA, if Nova had not leaked to the upstream provider, to peer 1, and they would have flagged it as an invalid relationship, that issue wouldn't have happened. And BMP, it wouldn't have taken 72 minutes to detect any of this. It would have detected it instantly. You stream your RIB, and you validate things, and you can learn it immediately. So who's filtering now? 50% of global prefixes, and this was 24, so it's even higher now. People are going towards it. It's happening. Coverage doesn't mean enforcement. Obviously, everyone's not enforcing it today because they don't want to black hole traffic or block traffic, but it will. So it's time to start. It's time to start planning of what-if scenarios. What if you drop traffic? What would happen? What if you blocked some things? What would happen? You need to do these what-if scenarios before you obviously go and do it in your network. One day you enable in your network, hey, drop all these prefixes which are not validated. Well, maybe half of the traffic will be gone. You can't do that, so you need to sort of have this study before. Who's doing ASPA? As the gentleman already pointed out, Aaron is obviously way ahead. Aaron and Ripe, they are already providing the tools. Apnic, Lacnic, Afrinic, they've all committed to doing it. And current deployment is less than 1%, but having said that, you start somewhere. RPKI was in the same situation 5 years back. It's now more than 50%. We'll get there with ASPA. We don't want to take another 5 years to get there. We want to do it quicker. That'll really help routing. But the tooling is ready for many things. What can you do with ASPA today? The first thing, sign your ASPA objects. List your upstream providers. If your upstream providers change, go back and change them in Erin or Ripe. And tier 1 providers obviously sign with AS0 with no upstreams. Monitor. This is very important to monitor today what's happening in your routers. Start with one router. Even if one border router you monitor, you learn today what is happening and what would happen, a what-if scenario. What would happen if I dropped these unverified RPKI objects or these ASPA path suspect objects? What would happen then? And yeah, talk to your routing vendors. Every routing vendor has it on their roadmap, including mine. Either it's close or it's going to come next year, but talk to them to get it faster. You want to start quicker. Why BMP? It's available since 2016. It's already there in most routers. Every router has it. You have pre-policy, post-policy, adjacent ribbon. You can get that info. You know what is coming from different peers. You know after your import policy what is in your routers. You know that. You know best path decisions. You know peer up, peer down. You know all of this. From there, you can find out already any real-time changes, any problems with RPKI, and so on. There are many open source collectors and even commercial ones. I didn't list any Nokia, as you can see. There's a lot of tools available for you to do all sorts of BGP monitoring. Before I go to the demo and quickly show how we can sort of do it today using the tools we have, I just wanted to quickly talk about what's changed. Most people have started, of course, being serious about their network, putting BGP guards in place, not taking BGP for granted. There have, of course, been, route origin validation is happening, ASPA is available. 3 weeks back, the White House published a routing security roadmap in which they are also stressing on RPKI and ASPA. You should be doing it. There are gaps, though. Everyone's obviously not done origin validation or signed their routes. Tier 1 still accepts /32s, as we saw from this failure in Cloudflare 2 years back. ASPA adoption is low. BMP direction is there, but it's rare. People don't use it. And of course, internet exchange route server filtering is inconsistent. Let's talk about what we can do. And this is an open source tool, which I'm going to demo. I have it running on my laptop. I started it in the previous talk. It's already downloaded objects from RPKI objects from RN and RIPE live. Thankfully, the place had internet connection, so I was able to show it. But what it does, it basically does 3 things. Ingests BMP. I'm using FRR routers in the demo, obviously open source routers, so that there is no issue with whose routers are showing, but you can get BMP route messages from any router. Gets RPKI objects, gets ASPA objects, validates and tells you, and of course alerts you of any anomaly. The demo I'm showing today, so I have to set it up first. What I have in the demo on my laptop, I have FRR routers. I have 3 FRR routers, actually. One is acting as the internet. There's a cloud near the internet. It doesn't appear very well on the projector, but that's one of the routers. I'm going to use that for demonstrating any routes coming from, let's say, the internet, which I'm going to introduce some error routes and so on, so that I can show failures. I have 2 FRR routers. I have Routinator running, which is an RPKI validator, open source. It's getting objects from RIPE and RN live. And of course, I have the tool Raven itself running, which is getting BMP messages and these RTR objects from Routinator and validating things. And I have some Grafana dashboards, and of course, there's a CLI to show you things. Let me show you the Grafana dashboard first before I demonstrate a scenario. So, as you can see, it has got 828K live objects from RIPE and RN, and it's showing that it's getting BMP messages. It has 5 routes. There's a route with origin invalid. There's one invalid, unverified route. How do I know that? I can show it to you. So this is what is in its routing table today. Currently, there's an unverified route. There is an origin invalid route. And of course, some of them are verified routes, which it's able to verify from the objects it's getting from the RTR objects it's getting from Routinator, which is coming from RIPE. What I'm going to do is I'm going to introduce a problem in the middle, obviously. For the sake of time, I'm only going to show one problem, a route leak, but you can do many sorts of hijacks, route leaks, and so on. So there's an object which I'm going to introduce. I'm going to say that instead of RIPE obviously has 193/21. It's a valid object. I'm going to introduce a second, which is called 172, which is going to say that it's coming from 6500, AS6500 instead of directly from RIPE. So basically, this is an ASPA path validation problem. Once that happens, the system should detect that, hey, you are not allowed to send me this route. This BMP message, which is sending me this path, this AS path is incorrect. I'm not supposed to accept it. It should show me that's a mistake. I have a script so that I can quickly set it up. And now if I go and see my route table on Raven, as you can see, it's introduced a path suspect, which is the second line. It's showing that I have received something which is not correct. For some reason, Grafana always takes a minute, not a minute, but a little bit to update. Let me refresh it. As you can see, path suspect counter went up by 1, showing me immediately that, hey, I received something which is not from the correct path. You can do this with today's routers, any router today, using a tool like this, or this tool, which is going to be open sourced today, hopefully. And you can find out everything today. Let's see a what-if scenario, or let me see first a recommend scenario. It's basically telling me, hey, you should ask your providers who are sending me, I have these many routes. One of them is observed, but it is missing a status. You should ask this status to be included. Otherwise, if I start blocking things today, I'm going to drop that. I'm going to drop that object today. You can learn these things today. You can sort of do this analysis today in your network. And you can also see what-if scenarios, which is telling you, hey, I have 80% I have some unverified routes. I have one route which would be dropped today if I sort of started blocking, and which path would be blocked and what would be affected. You can do this today using the tools you have. You don't have to wait for your routing vendors or your router vendors to sort of develop these today. You can do this today with your routers. And like I said, start with one border router. Get the BMP messages from there. Find out what is in the tool today, what is in your network today, what objects are valid and what not, and what would have happened if you dropped something or not. You can do this directly today itself. The what-if rejections, why should I do it today? Well, that's how you know what would happen if I tomorrow started enforcing RPKI. And also, it tells you who around you should talk to, who your peers are, and who you should talk to about what objects. If they are not signing their objects, if they are not making the enforcements, if they're just passing on these messages to you, invalid messages, you are going to drop them. And this is why I said, the community is really needed for this. You need to have contacts with your NOC, with your peering NOC, and so on, to discuss this with them and tell them, hey, you guys need to do this as well. Otherwise, you're sending me these invalid messages. Key takeaways. Operational hygiene is the foundation. It's not sexy, yes. No one writes RFCs, like I said, on this. Maybe they should. You should have. I mean, there are so many RFCs which are like, best practices. Maybe we should have some of these in there as well. But yeah, those are all important to do and should be done. Signing is necessary but not sufficient. Just doing RPKI is not enough. We need to do ASPA. And you can do it today. You can go to ARIN and RIPE and today sign your objects, declare your upstream providers, and if they change, go back and correct it. Build the full security stack. You can do this today. You don't have to wait. You can do this today with RPKI, ASPA, and BMP. You can figure out things on your own and sort of learn about it. And it's a collective effort. If only one vendor does it in the middle, or one network does it in the middle, or one AS does it, it doesn't help much. You saw the charts Brad showed before. As more and more people do, it gets isolated. The attacker gets isolated. That's only going to happen quicker if everyone does it. So it's needed to sort of do these defenses together. So the question is not how we start or should we start, it's how fast we should do it. and you'll still be vulnerable unless you do it. That brings an end. I have 2 minutes. Any questions?
As Ritesh just said, we have about 2 minutes for questions if you want to ask about the new tool or anything that you just covered today.
The tool, I don't have a link. I would have had a QR code with a link and so that you can just immediately go to it, but I have not published it yet. Like I said, today morning was the meeting to it, so I had to sign the paperwork, so which signs my life away, but it doesn't really sign my life away. Open source is open source, but it basically just is to protect Nokia. Okay, we will talk. Go ahead. You can come to the mic so that everyone can sort of listen.
Yeah, so when you did that Raven example, right, like that was from the perspective of an upstream of the AS65000, right? Like because it like
yes,
if you're not an upstream, they could have a peering relationship, right? So I'm just kind of curious how your tool validates the peering relationship.
So if you look at ASPA, the draft, it says that it's valley-free routing, right? I mean, in the sense, who are your upstream providers, the ramp up and the ramp down. So we are trying to monitor both. If you don't fall in the path, if you are in the middle trying to announce something and sort of trying to circumvent that valley-free routing which we got, then we will flag it. So the tool, what it does, it sees the AS path and sort of your BMP messages. From the BMP messages, it knows who is connected to me and who is sending me these messages and what's in their route tables. So that anytime anyone sends me a message, it sees that, hey, you received this update, this BGP update, which I got from BMP, and you are not allowed to send me this, adding yourself as the AS path. That's what Raven is doing. So it knows, no, this is not you. You are not in that AS path. You should not be sending me this message. And today, you can say the only thing you can do is you can drop that message, don't accept it. But my take is you should be telling your peer who send you that message, hey, that's your mistake actually. You shouldn't be sending this to me. So you tell their NOC, guys, come on, you guys got to be better than this kind of thing, you know. That's the idea. But yeah, that's what Raven is doing, is just verifying the valley-free routing.
Yeah, that makes sense. I actually read the standard at one point. And like the one thing I would like to mention is that like you should also get your upstreams and their upstreams to sign like ASPAs, because that will help constrain like the up ramp.
Oh, absolutely,
Yeah,
absolutely.
So there's the additional benefit. Like if you sign it, it helps your customers validate like AS paths. That's the one thing.
Absolutely, yeah, that is a must. Yes, that's of course. Okay, thank you.